Welcome to Across the Globe. Today we will learn about APIs in Python. API, Application Programming Interface, serves as a standardized set of rules and protocols enabling software applications to exchange information and work in concert. In Python, APIs are frequently employed to interact with external services, including web APIs and databases. For instance, a Python program might use a web API to obtain weather data for a particular location or retrieve information from a database to display on a web page. When working with APIs in Python, the request library facilitates sending HTTP requests to designated URLs. In requesting data from a web API, utilizing the requests library entails conducting a GET request towards the API endpoint. Subsequently, the response data can be obtained for further processing or utilization. Slide 4. Title: Authentication in APIs. Content: APIs often demand authentication for resource access, which involves utilizing API keys, OAuth tokens, or similar techniques. For instance, to authenticate using an API key in Python, you can include it in the headers of your request using the authorization field. Following this structure, an implementation may resemble Python import requests headers equals authorization bearer your API key. Response equals requests.get.example.com/data headers equals headers. Data equals response.json print data. By passing the API key in the headers, you authenticate your request and gain access to the API's data for subsequent usage or processing. When interacting with APIs, it is crucial to implement error handling mechanisms to maintain the stability of your application. One common practice is to utilize try-except blocks to capture and manage exceptions that may arise during API calls. In the provided Python example, a try-except block is used to handle potential HTTP errors that could occur when making a request to an API endpoint. By encapsulating the API call within a try block and specifying the exception to catch in the except block, you can gracefully handle errors without crashing the program. This approach enables you to log or display informative messages to users in case of errors, enhancing the robustness of your application. An API is like a menu at a restaurant where customers can order specific dishes. Each dish on the menu corresponds to a specific function or capability that the API provides. Just like how the chef prepares the dish based on the order, the API processes the request and provides the desired output. A Python program can act as the waiter, taking orders from the customers, user inputs, and communicating them to the chef API to fulfill the request and serve the output. Hey, code conquerors! Ready to level up? With TechLearn ATG, showcase your skills with official course certificates. Just visit our site and start. Need that extra boost? Get tailored learning, 24/7 support, and expert guidance. Coding smarter, growing faster, and making learning fun. Go to our website across the globe, www.atg.world. The code defines a dictionary menu that serves as an API menu with 3 dishes: get data, process data, analyze data, represented by keys 1, 2, 3, respectively. The process order function is responsible for simulating the chef processing the order selected by the customer. Furthermore, the take order function simulates a waiter taking orders from customers. It presents the menu options to the customer and prompts the user to select a dish. The customer can enter 0 to exit. If the customer selects a valid dish from the menu, the process order function is called to process the order. The main program runs the take order function when executed. It provides a user-friendly interface for customers to interact with the API restaurant, choose dishes from the menu, and have their orders processed accordingly. Real-world use case. This code structure can be applied in various API-driven platforms or systems where users interact with predefined capabilities or functions. For instance, in a data processing service, users can select different data manipulation operations, such as fetching data, processing it, or analyzing it, which are implemented as API functionalities in a structured menu format. This approach simplifies user interaction and allows for seamless processing of requests. One common real-world example of using APIs in Python is in web development. Web developers often use APIs to interact with external services or resources, such as fetching data from a database, integrating payment gateways, or accessing social media platforms. Python's requests library is frequently used to make API calls and retrieve data for web applications. Another example is in data science and machine learning applications. Python provides various libraries and packages such as NumPy, Pandas, and scikit-learn that offer APIs for performing data manipulation, analysis, and modeling tasks. Data scientists and machine learning engineers utilize these APIs to process and analyze large datasets, build predictive models, and deploy machine learning algorithms in production environments. In conclusion, APIs in Python enable developers and data professionals to streamline their workflow, access external resources, and enhance the functionality of their applications across various industries and domains. Keep learning, stay curious, and I'll catch you in the next video.